Okay, so now we're going to talk about oxidation states and what that means. So oxidize, that word, or oxidation, is named for the atom of oxygen because oxygen is extremely electronegative. And if you'll remember, earlier in the course, you studied periodic trends, and electronegativity has a trend on the periodic table. And so our most electronegative elements are going to be those in the top right. So as we move up and we move to the right, they get more electronegative. So oxygen is one that's extremely electronegative. And what does that mean? That just means it really likes to pull electrons toward it. It loves to take electrons. So a lot of times what happens is if you combine oxygen and another molecule, the oxygen is going to be a hog. So think of oxygen like a pig. It's hogging everything. It's going to pull all the electrons towards it. For example, water. Remember when we did Lewis dot structures, we had to figure out which atom was going to be the most electronegative and put it in the center, because the one with the most electronegativity was going to pull the electrons toward it. So it's the same concept. So obviously in this case, we have oxygen and we have 2 hydrogen. What's going to happen is these electrons are going to want to hang around the oxygen. And remember, electrons are negative, so because they're wanting to hang around the oxygen, it's going to give the oxygen a more negative charge. Okay? And these hydrogens, well, their electrons are trying to leave them. So it's going to cause them to lose that negativity, so they're going to have a more positive charge. Okay? So this is what we experience in covalent bonds. Remember, a covalent bond is when a molecule or 2 atoms, they share, or more than 2, whichever, they share electrons. So in a water molecule, they are sharing these electrons. So they're hydrogen's using them and oxygen's using them. However, that's compared to an ionic bond. Remember, an ionic bond was the metal on the left, the nonmetal on the right. They combine, and one gives up an electron and one takes an electron. So think of ionic bonds as being more extreme. They're giving up or taking. So it's more extreme. It's happening. Versus covalent bonds, that's our nonmetal and our nonmetal, and they are a lot nicer. They like to share and get along. All right. So what happens is, this makes things kind of confusing, because when we think about oxidation states, we're looking at, did it gain electron? Did it lose electron? So you can't really do that with a covalent bond, because hydrogen didn't gain or lose an electron, and neither did oxygen. They're sharing them. Even though oxygen is greedy and is pulling it towards it, it did not take it. So because it did not take it, it's not an ionic bond. But to determine the oxidation state of oxygen or hydrogen, we have to think about it in terms of if it was ionic. So we're looking at covalent bonds in terms of ionic bonds. So you have to think in a hypothetical sense. Well, how do you do that? Okay, well, if oxygen is the greedy one that's pulling everything towards it, if we thought about it from a sense of an ionic bond, is it going to take or is it going to give? Well, oxygen is greedy. It's going to take. So in ionic bond hypothetical sense, oxygen is going to take. So oxygen would be the one to take the electron. Okay, now we have 2 words, oxidation and reduction. And you might want to write these down. Oxidation means, or how is that? If it's oxidize, might make it less confusing. If an element is oxidized, it loses electrons, so it becomes positive. If an element is reduced, or compound is reduced, it gains electrons. and becomes negative. So if we're thinking about the one we just talked about, oxygen gained electrons. So that means oxygen got reduced. And oxygen will always get reduced because it's always going to do the oxidizing. So you have to think of it, they're flip-flop terms. So if oxygen got reduced, it oxidized the other element. If hydrogen got oxidized, it was reduced by the other element. So they're flip-flop. Okay. So the more, and this is not just with oxygen, even though it's oxidized, it's named after oxygen, it's not always going to be oxygen. It can be another electronegative atom, like sulfur. And so if you're using that one, it would be the one that does the oxidizing. So sulfur would take electrons from the other atom and cause it to gain electrons. So sulfur would get reduced and become more negative, whereas the other one would lose those electrons that sulfur took. It became oxidized and became positive. So really you need to memorize this. And here's a little trick to memorizing. It's called oil rig. And it stands for oxidation is losing, reduction is gaining. Okay? So if something is oxidized, it gained oxidation means it loses electrons and becomes positive. So if something gets oxidized, it got the electrons taken from it and became more positive. If something gets reduced, it got the electrons given to it and became more negative. And whatever element is reduced does the oxidizing. I would write that down. Whatever element is reduced or compound is reduced does the oxidizing, if that helps. Okay. So that's a type of reaction. They're called redox reactions. And that's why we have to think about them in terms of how they would behave if they were ionic bonds, because we look at it from the perspective of gaining or losing electrons. Okay? So, let's see. The last thing you mentioned were types of reactions. I'm not sure exactly how far you wanted me to go in that. I didn't know what you meant. However, I did find a really good table. I typed it in Google. I typed in types of reactions, went to Google Images, and they have a ton of tables. But any of these tables pretty much would work. It gives you the types of reactions. So you have your synthesis, your decomposition, single replacement, double replacement, your acid base, and your redox, which is what we just talked about. It gives you an explanation. It gives you the ABC examples that kind of show you like the concept, and then it gives you an actual example. So with single or combination, we're just combining two elements, we're putting them together. With decomposition, we're breaking them apart. Single replacement, we're just switching up one thing. Double replacement, we switch up both things. Acid-base neutralization, you're going to look for these hydroxide and hydronium or hydrogen ions in there. That has to be there. It has to be acid and base. An acid has the hydrogen, the base would have the hydroxide. And then we just talked about redox reactions. Okay, well, I hope that helps.